Hi, I'm Pappy Bedard. I'm a retired engineer and software developer and Cinema4D hobbyist. Welcome to my long overdue next tutorial. In this tutorial, I'm going to expand on the common idea to create slices using Voronoi fracture with offset fragments and plane effector scaling. I'm taking the idea a little bit further by making sure that the resulting stack of fragments accurately matches the object contour. My rig will also include controls to view one slice at a time to facilitate the creation of stacked laminate sculptures in real life. With that as my project, my tutorial will present my method of workflow as I build a reusable Xpresso rig and object hierarchy. Let's get started. So I'm going to start with a blank project, and we'll begin by discussing a little bit about the Voronoi fracture, how the points work, and how the gap works in relation to scale. So rather than use a landscape object, I'll just create a cone to simulate a landscape so we can better see what's going on. And I'll move that up so that its bottom is right at the 0. So I'll move that up 100. And we'll give it a little bit of a top radius, maybe 8, just so that it doesn't wind up with a point on top. And I will change its rotation segments to 12 just to simplify the geometry a little bit so we don't have so many lines to look at. And we'll go into this front view and change its display to Gouraud shading. And we'll put that under a Voronoi fracture by holding Alt, clicking on Voronoi, and it automatically makes it a child of that. So by default, the Voronoi fracture creates this point generator for you automatically with random points in it. I don't want to use that. Instead, it can use any object that has points. Virtually any Cinema4D object has points. So what we'll do, just to discuss this a little bit, I'm going to add 3 nulls, and I will change their shape to star, just so we can see them. And I'm going to move them out here somewhere so that in this view we'll be able to see them a little better. Actually, I don't see that one very well. Let's just move them up here. So we'll put one over here and one over here. So there's 3 points. Now the points that the Voronoi fracture uses don't actually have to be on the object, and I'll explain in a second here. I'm going to lock this attributes window temporarily so this screen stays on. Select these 3 nulls, drag them into the sources, and then unlock that. So you can see here that the way that Voronoi fracture sources work is that every point between any of the points, it creates a plane that slices the geometry. Just changes to quick shading lines. You can see that this line corresponds to a plane exactly halfway between the middle point and this point. And you can see as I move this plane intersects that midpoint of those two. And it's the same with this one. If I move it down here, these 2 planes are exactly halfway between those points. And between this point and this point, the 2 far ones, it created this plane. So that's basically how it works. So I'm going to delete these points, and instead I want to put an object that I can more easily control parametrically. So what I'm going to do is create a helix, put it on the XZ plane, and make its start and end radius 0. The way I do that is I can control click on the start and end radiuses. You see they're selected. Then while holding down the control key, I can change one value and they'll both change. And then we'll make that the source for the Voronoi fracture. Now, if I click on helix in this attributes window, it opens up this. And right now it automatically distributed an even number of points, 20 points. I don't want to do that. What I want to do is use the points that are actually part of the helix. So I'm going to change this to vertices. And so now all of these points are actually vertexes in the helix. And that's controlled by this subdivision parameter. So I'll change that to 4. So I only want 4 subdivisions. So to make 4 subdivisions, it actually created 5 points. Can you see them here? Now again, between each of the points, it puts a cut plane. So this object is 200 centimeters high, and I created 4 subdivisions. So each one should be 50 high. But what it did, because of the orientation of the points, the 3 middle ones are exactly 50, but then it created half and half, top and bottom. Each one of those is 25. So we're going to deal with all of these separately when we move on here. So the next thing we want to do is take a look at the Voronoi fracture object tab and see how offset fragments work. So we know that these are 50. So let's say I put 20 in here, offset by 20. So for each of the sections, it subtracted 20 from each side. So what that should leave is 10. So in other words, so let's say I put, how would I get 1? Right now this is 10. I want that to be 1. So let's figure out the math here. So 50 minus 10 is 40, divided by 2 is 20. So if I want this to be 1, I could say 50 minus 1 is 49. Divide that by 2 is 24.5. So this now is 1 centimeter. The next thing we want to do is scale that so that it fills up this gap. Now this gap is now 49, right? Because there's 1 and then 49. That would make 50. With Voronoi fracture selected, I will choose a plane effector, and by default it puts the let me go back to Voronoi fracture. On the effectors tab, it puts the plane effector in here because I added it while Voronoi fracture was selected. Going back to the plane effector, it defaults to a position change of 100 centimeters in the Y. I don't want to change the position. I want to change the scale. And let's see how scale works. So right now that's 1 with a scale of 0. If I change the scale to 1, so now we've got 2. So I want to fill a gap of 49, so I need to change this to, is it 49? So I'm temporarily now going to show lines just to show you that if the number is greater than 49, let's say I put 50 in here, I have to subtract the original, I have to subtract 1 because we have the original thickness. Go back to the quick shading with lines. So before we get too far, let's start building a rig now that we know some of this math and how it works. So do a little bit of organizing here. Since this eventually we want to create some kind of an object we can save as a resource, I'm going to select all of these objects and then type Alt G to group them. And then I'll change this name to topographical slices. And on that null, I'll put a programming tag, Xpresso, and I'll drag the Xpresso in here and expose those two. Oh, I don't have anything yet. Let me, on the Xpresso tag, create some user data. So I'll hit Manage User Data. I'll add data. So one of the things we're going to need is the segment height. That would be the 50. And we'll make that a real, and we'll default that to 50. And we'll create some more data. This one we'll call original slice thickness. So that's after applying the gap, the slice we're left with. So I'll call it orig slice thickness. And we'll default that to 1. Also make that a real. I'll make the default value 1. Okay. So now going back to this, our Xpresso should have those two user data parameters. So there's the segment height and the original slice thickness. And if you remember the math we did when we set the offset, so eventually what we're going to want to do is set the, let's expose this parameter, the offset fragments from voronoi fracture. So we're going to do some math on those two and plug it into offset fragments. Well, if you remember what we did is we took the segment height, we subtracted the original thickness, and then we divided by 2. So let's do that math. So go over here to the calculate, and we'll grab a math node. Now, the math node always says math add, but you can change that add to other operations. What we want to do is change this node parameter to subtract, and we want the segment height minus the slice thickness, and then another node, and we're going to divide by 2. So it changes to divide. Change, all right, the first parameter is this. The second parameter is 2. And then we'll plug that in to the offset fragments. Now let's test that. So we'll go back to here, and we'll change this 1 to other numbers. Just so we can see what's happening, I'm going to temporarily turn off the plane effector. So back to our user data, and now we can change, you can see now as I change this, obviously it can't be more than 50, but let's say I make this 10, so that's the slice thickness is 10. Make it 1, now the slice thickness is 1. Make it 0.5, now it's 0.5. So that works. Now we'll turn the plane effector back on. And we got to do one more thing. We got to create this scaling. So for that, we'll go back to the rig we started. And the plane scaling, obviously it's going to affect this. And we want to expose the parameter for transform SY. That's scaling in the Y. All right, so I'm going to drag this to divide. We're going to divide the segment height by the slice thickness. and then subtract 1 from that. I'm hitting Control here and dragging that just to grab that. I'm going to subtract 1, so I'll put 1 as the second parameter, and this is the first one. And just to double check our results here before we connect anything, I'm going to add a result node. Change this color to red just so I can reuse it, and it'll be noticeable. So the output from that is 99. Now why is that? Go back to my, because we have a half here. So if I change this to 1, 49 was the number we used. So that math is working. So I'll plug that in. So now both of these parameters should work. So go here, and as we change the original slice thickness, now let's take a look at the other views. This view here is going to be our kind of a topographical look. So we'll display that as quick shading. So the issue here is with this slope on the side of each of these segments, it's not really dividing it into nice clean slabs with this slice thickness. So the smaller we make that, the less that's noticeable. Can't be 0, obviously, but it could be really small, like 0.1 or 0.01. So the smaller we get, the more accurate these cross sections are. Now we still have some issues. Go back to this view, click on cone so you could see the outline of the cone. So these corners are really not in the right place for this to be an accurate topographical representation of this cone. I want to move these down by half of this slice thickness so that this point winds up right in line with the cone. I don't want to do it for the bottom one, but on the other ones I do. So on the plane effector, I'm going to add a formula field. And the formula is going to be, for now, ID greater than 0. So you could see now, if I go back to this view, it's not affecting the bottom layer at all. So in other words, this plane effector scaling, it's not being scaled, and it's not being moved. Well, none of them are being moved. I want to change this position to -25. Go back to this view. Now, the reason I picked -25 is 25 is half of 50. Now, if I select cone, you can see that these ridges line up perfectly with the cone, which is the way a topographical map technically should be. So the bottom we're going to deal with later, and the top. Well, let's deal with the top now. Why didn't the scaling work? Well, because if you remember, without the plane effector, let's put this back to a bigger number so we can talk about this. So we'll make that 1. This was only half the height of the others. So we need to, the scaling has to be double. And its position, whereas all of these are centered around the point, this one on top is not centered. So we first have to move it up by half of this, and then we scale it by double. So let's make another plane effector to deal with that. I'll just do a little bit of housekeeping here. I'm going to rename this plane mid for the mid sections and formula field mid. Then I'll copy this, and we'll rename this top, and this top. Now, how should I identify this? Well, let me see what the variables are. So where is that point? It's basically it's at 200. So to make sure we get it, we'll say that py is greater than 200 minus 50. So that'll guarantee we get the top only. Let me just verify that by turning this effector back on, and then we'll just make some changes here. What I missed was in my Voronoi fracture effectors, I've got to add this. Okay. So obviously we've got something way crazy going on here. Let's go to plane top. We'll change the position to 0 and the scaling to 0. So remember what we had to do. We had to move it up by half of the amount. Let's turn off the effector first. So click on cone. I'll turn off all the effectors. So we have to move this up by half this amount. Well, remember, this original slice thickness is 1. So this is half of that. And we want to move it up half of that. So it's really the original slice thickness divided by 4. So that would be 0.25. We have to move it up. Turn these effectors back on. So up by 0.25. And then we've already scaled this, but we had to double scale it. So we're just going to put a 1 in here. So that should correct that. So now let's add that to our rig. So we need the original slice thickness divided by, we need to divide it by 4, but it has to be a negative number. No, it's got to be positive. So just change this to a 4, and that'll be the input. And the result is going out into plane top. And the parameter is transform py. Okay. Try to keep these things somewhat organized. All right, so now that should work. Going back to our rig here. So as I change this, everything kind of lines up. Now, what do we want to do at the bottom? Let's take a look at it. I think all I want to do with this one is move it down by this amount. Oh, but before I do that, I don't think I finished this mid. Yeah, this little symbol here indicates that Xpresso is controlling this variable, but I just typed in -25 here. We need to put that in as part of our rig. And all that was the segment height divided by -2. So I'll change that to -2. And the segment height divided by -2 is going to, just push this aside here. That's going to go into the parameter transform py. So we're going to position, just drag this up to make it a little less. So now that's correct. So now let's deal with the bottom. We just want to move this down that height so that the top of it is in line with 0. So we are going to, well, before we open that, let's create another plane for the bottom. Make sure we copy it into here. And we'll rename this to bot. And this one to bot. So the formula for this one is going to be, say, py is less than 1 for now. And it's not going to have any scaling. And we're just going to move it down by by 1. Let's see, why is that? What do we, oh, because we got our original slice thicknesses 2. If I change this to 1, then this has to be minus 0.5. So it's just the original slice thickness divided by minus 2, and that'll be going into py. We'll just make another one, divide by minus 2, and we'll put it into the plane bottom, into parameter transform py. So original slice thickness. Let's just check that result. Yep, minus a half. So the next thing we need to do is make use of this segment height parameter. So we know this is 200, and if we put a 50 in there, then we get 4 sections. So 200 divided by 50 is 4, and that just happens to be what we put in the subdivision. So we want to plug in this so we can start using that. So put the helix in here somewhere, and we want its subdivision to be exposed, and well, rather than just put a 200 in there, let me actually grab the, I'll put the cone over here. I want to grab the bounding box, expose the object here. And what I want is the box size, but only in the Y direction. Each of these, if you right click and look at port information, it's actually a vector, which is an X, Y, and Z. So what I want to do is do a vector to reals, extract this box size, and then let's just put, I'm just going to copy this result up here. Let's just see what the result is. The result is 0. Well, that's because cone is a parametric object, but I want to keep it parametric. I don't want to collapse it. The way we can deal with that is by putting a correction deformer under it. So I'm holding down Shift. And then instead of using cone here, we'll use this correction deformer. Expose its object, plug that in here, get rid of this. So now you can see the result is 200. 200, I'm just going to grab this divide. So 200 divided by the segment height, that should equal 4. So I'll put this over here. It does. So I'm going to make that the subdivision. Now this 50 should work. So let's change this to 40. 20. Something went wrong here. What is it? If I disable the top plane effector, it's okay. So there's something wrong with this. So let's look at the formula. Yeah, I had hardwired in 200 minus 50. That was the total height minus the segment height. So we need to build that into our Xpresso. So we'll put the formula field here. Now, if you remember, this result was our 200. And 50, or whatever the segment height is, it's 20 now. So it should say 200 minus 20. Now, we're going to expose the formula, but let's see, the port information for that is it's a string. So we need to get a string in there. So we're going to have to convert some numbers to strings. And to do that, we will use a Python node. And this output by default is a real. I can't have that. So I'm going to delete that port. And instead, I'm going to add a string as an output. And the two inputs, those are both reals. Those are okay. So 200 and 50, and we got to put a little bit of Python in there. I'm going to rename this size. And I'll rename this one to thick. And I'll rename this one to formula. So I'm going to open the Python editor, and inside that node, what we want to do is make formula equal size. No, what we want it to do is say something like py is greater than size minus thickness. But that won't work unless we build a string out of it. So we want that plus the string of size plus this plus the string of thick. And we need a parenthesis in here and parenthesis in here. So that's going to create a string for us. And let's test that. So plug formula into here. And then go to formula top. Yeah, it now says py is greater than 200 minus 20. So now that should work. So going back to here to test it, changes to 10. 5. How about 30? Whoa, something went wrong. And the reason is that 30 doesn't evenly divide into 200. But those other numbers I was trying all do. So 25 evenly divides and 50. So I will fix that a little later. But first, we need to organize our object tree here a little bit better to make it more adaptable to plugging in other objects. Right now, I have a cone in here, and let's say I wanted to put a landscape in there instead. There's two ways that a deformer can apply to an object. One way is by making the deformer a direct descendant of the object. Another way is to put them under the same hierarchy. So I'm going to hit Alt G here. So I put it under a null. And to do that, if they are at the same level under an object, then the correction deformer will affect it in the same way, even if this is also under a group. So that would work. I'm going to call these objects. And the correction deformer will work under that. Now, let's say I wanted to put more than one object in here. I might want to connect them. I'm at a connect object here, and then I'll put the correction under that, and then the objects under that, not under it, but same level. Since I was moving things in and out of different hierarchies, I want to just make sure all the Y positions remain the same. So I'm going to select everything, go to coordinates, change all the Y's to 0, and then change the cone to 100, just to make sure everything is set correctly. Now, let's see what happens if we make the cone height extend above where this helix is. Let's look at much more layers. All right, so what happens now if this extends above that point? So I'll go to the cone. I'll make the height, say 250. And make sure it's still on the floor. Wow, it went way out of whack here. Why is that? Well, change this back, put it back on 0. Here's the reason. In here, we're using the height of the object to determine the subdivisions of the helix. What we have to do is set the helix height so that it's at or above the height of the object and an exact even multiple of the segment height. So we'll start out by breaking this by putting a number in here that doesn't evenly divide into 200. Okay, so we just broke it. So let's fix it. We'll start out by pushing these things off to the side and disconnecting the size. That's where we're using the 200. What we'll do is we are going to divide 200 by the segment height, and that will give us a new answer. So we need 8.69 segments, but we have to have an even number, so we have to round that up to 9 somehow. Luckily, there's a float function here that allows you to pick different functions for floating numbers, and one of them is called ceiling. And if we plug that 8.6 into it, what we'll get out is the next perfect integer, which is 9. And then what we just need to do is multiply 9 by the segment height to get a new height. So I'll just grab this here, change it to multiply, and we're going to multiply 9 times segment height, and that will give us this result, 207, which is what we need to have for the size. And we also need that here. And let's see if that fixes it. Let's see, what is the helix? The helix is still 200. It should have changed. Oh, the helix height is not tied to anything. Let's go back here and see what's going on here. Oh, here's the helix. We just have to expose its height right there. And we're going to use that output for its height. And its subdivision, we don't really even need this divide anymore because 9 should be the number of subdivisions. So I'm going to copy this over to here and then delete this node. Now let's see if we can move these around to clean them up a little bit. It's kind of hard to position these without having wires all over the place. I'll get rid of these two. All right, that's not too bad. Did that fix it? Yes, it did. So now we should be able to have any segment height we want, and it will automatically adjust the size of the helix spline, as you can see. The next thing I want to do is to make sure I have these formula fields tied in, like this one is not. So let's take care of that. Formula field mid. So we're going to bring that in here and expose its formula. And we're going to need a Python similar to this, but without the size, just the thickness. So I'll delete that port. That formula is going to plug in there. It's going to optimize this a little bit. And the thickness is just going to be this. And the reason that turned yellow is there's an error in here. That's because we have the wrong equation here. So we want this just to say Py is greater than the string of the thickness. That's it. So now this should say Py greater than 1. And if we change the slice thickness, that will update. The next one, that one's already tied in. The bottom, well, we've got ID equals 0, meaning the ID of the first slice of the voronoi. Now, that's not a good idea to use that. A cone happens to have only a single object, a single item at the bottom, but there are other objects that may have more than one. For example, I'm going to just hide this cone here, and instead I'm going to add a horse. And we will get that horse underneath the objects here and make sure it's on the floor. By the way, I'm clicking on this drop to floor button. That's a free download. It makes sure that the bottommost vertex of any object is right on the 0xz plane. And I'll provide a link for that in the description. So there's our horse. Let's maybe make it like that. See how that looks. Not bad. Let's look at the bottom feet of the horse. They're not quite right. Because, it's hard to see in this example, but if instead of using ID equals 0, I said PY is less than 1. See how that just cleaned it up a bit? That is because with ID 0, only one of these horse feet bottoms is ID 0. The other 3 are 1, 2, and 3. So to make sure we get all of the bottommost segments, we need to do something like PY is less than 1, similar to what we did PY is greater than 1 here. So we're going to add that. It's basically a copy of these two things. Well, not this one. I have to actually drag in the bottom and expose the formula, connect that, and connect this. I need to change this to less than. So now it should be good for any parameters we care to set here. So let's get the horse out of here, hide the horse, and unhide the cone. So next we'll see how this rig works on a landscape. So we will hide the cone and add a landscape. And let's make it a little bit more interesting. And we'll drag that under the objects. Okay, it seemed to work, except for we seem to be missing all the surfaces. And the reason for that is on the Voronoi fracture, there is a checkbox that says optimize and close holes. So there's our landscape. Let's play around with the parameters a little bit. Let's make the segment height 4. You know, instead of using the Voronoi fracture color fragments, let's add a material to this. So I am going to create a new material, throw it on the Voronoi fracture, and we're going to give it a texture of a gradient, but not the standard one. We're going to make it a 3D linear, and we want it to start at 0, 0, 0 and end at 0, 200 to start with, and let's make it world space. So we should have a different gray on each of the various elevations here. This almost looks too smooth here, so what I'm going to do is go back here and change this to maybe 25, maybe 20. So each of these plateaus has a different color. And we made the color map from 0. Let me look at that again, this one. It goes from 0 to 200. It says cycle. I'm going to turn off cycle because we don't need it to repeat black to white over and over again. So what would be nice is if we could tie this 200 where the white is to maybe the height of the helix. So let's do that. We'll open up the Xpresso, go back to that color. There doesn't seem to be a way to drag either a, well, let's see, I can grab this, but then there's no way I can input anything to that material. So that's not the way to do it. Here's a hint. I'm going to make the helix, I'll close that for a second, the helix height a driver by doing expression set driver, and the color gradient Y driven. Well, it seems to be bundled into this vector here, and I can't set just the 200 unless I do this. Right click on the name and change the user interface to show subchannels. Now if I click on just the Y, not the name, that selects all three, but if I just click on the Y or the X or the Z and right click, then I can set driven. And you can see now it's changed to 140. So now if I change the height of my landscape, it always goes from black at the bottom to white at the top. Very nice. Problem is we have an extra bit of, what it did is it created a null called expression, and it added this little bit of Xpresso in it. But what I can do is copy, I'm selecting gradient and then say edit copy, close that, and then open the one we've been working on and edit paste. Let's see, where did it put it? There it is. So I'm going to drag this, and we need to make it driven by the helix height, which is the same as this. Now I can get rid of this whole object. And that color now will be forever associated with this rig. Another thing to think about is instead of using a black to white gradient, we could load a preset for a gradient that is specifically designed to show elevation. This one here, I was actually able to download and convert it to a gradient from the internet. And I actually have a separate tutorial on how to do that, so you can check my channel. So we're going to select this as, and it's sort of backwards, so I'm going to invert it. So black's at the bottom. So those are like standard map colors for gradients regarding elevation. So now I'm going to delete the landscape and unhide the cone. I'd like to move on now to stacked laminated sculptures, similar to these kinds of things, where we take slices of an object and cut each slice out of some material like plywood or plastic, and then glue them together to create a sculpture. Now, what would be handy to create for creating sculptures like this would be if we could isolate one slice at a time and print it. So I'm going to move on to that next. So I'm going to start with the horse. So I'm going to get rid of this cone and put the horse back here. And we'll give this quite a few more laminations. Let's say, I think 4 was a good number for this horse. And we can make them much cleaner 90-degree corners, as close to it as possible. So how can we isolate one layer at a time? Well, we can do it with a formula field and a plane effector. I am going to copy this here. We'll rename it plane hide because we're going to be hiding most of the segments. And we'll call this one field hide. And this is going to be, let's see, how would we isolate one layer at a time? So if it's less than 1, then what? Then we don't want to move it. We just want to change its visibility. Let's see if that works. So I need to copy that new effector into here. Let's say less than 4, less than 8, and py greater than 4. Yeah, so we just need to do some kind of a py less than and py greater than to isolate different layers. So let's take a look at these variables. I'm actually going to make use of this frequency variable, which we can feed from Xpresso, and make that represent the slice, the vertical slice we're talking about. Let's go into here and create some new user data. So we're going to add data, and the data type is going to be a separator, and we'll put a bunch of dashes. And then we'll add some data, and we'll call it show one slice only. Show one slice only. And we'll make that a Boolean, a true or false. And then we'll add some more data, and we'll just call this one slice to be the number of the slice we're interested in. And that is going to be an integer. And it should range from 0 to, let's make it 1,000. Never know how many slices we're going to have. Default's 0 for that. Default is off for this. So we'll hit OK. So now we've got these 2 extra pieces of information here. So now we can go into here. And rather than expand on this, we're just going to drag this in here again. And we'll expose show one slice only, slice, and we're also going to need the segment height. And we need some Python. And we're just going to rename this port to segment, I guess, because that's going to have the segment height. The plane effector is either going to be active or not, so that's a basic property. It's going to be enabled, and that's going to be controlled by this Boolean. And then we need to add the formula here and expose the frequency, that's a variable, and the formula. So the frequency we're just going to set directly from the slice. That's a number. And then the formula is going to go in here, but now we need to edit this Python. So I've already worked it out. In the interest of time, I'm going to copy and paste it. That is what is going to create our formula field. So this is what it did. It says Py is greater than or equal to 2 plus 4 times F minus 1,000th, and Py is less than 2 plus 4 times F plus 1,000th. Or where'd the 4 come from? Right here. And the slice came from there. So let's test it. We need to do it through here. Enable it. There's 0, 1, 2, 3, 4. Let's look at it from the top view, which is kind of cool. And let's scroll through those. So you could, if you cut out all of these sections and glue them together, you'll wind up with a horse. Pretty cool. And we'll turn it off to see them all. Now, what if instead of doing horizontal slices, you wanted to do vertical slices? You can't just rotate the helix. That causes a bunch of problems. But you can do it this way. Click on the object, in this case the horse base, go to its coordinates, and actually I'm going to zero this out first. And make it sit exactly on the floor. Okay. Actually, since I've been moving things in and out of this hierarchy, I'm going to select everything, change all the Y's to 0. So everything is nice, and then with the horse base, make sure it drops to the floor. Okay, now back to the horse base. I can, these rotation H, P, and B, if you didn't know, that stands for heading, pitch, and bank. Anyways, let's make the bank 90 degrees. That turns the horse on its side. But we need to drop it to the floor again. Then we can go all the way up to the top of this hierarchy, the topographical slices, and make this bank the opposite, minus 90. So now we have horizontal slices. You could do slices in other ways too, depending on which of these 3 components of the rotation vector you change. So it still works just like it did before, so we could make smaller slices. That could come in handy. It also still works with this. So you cut those slices and glue them together, and you'll have yourself a horse. So now that we have all this working, let's reset everything. I'm going to get rid of the horse, get rid of the, well, I'll move the cone back under objects. Actually, we'll just make sure everything is zeroed out properly. And the cone is on the floor and it's unhidden. Something's off here. Oh, my angles. Change that to 0. Change that to 0. Now recenter everything. Make that 0, make that 0, make the cone on the floor. Okay, so this might be a good time to save this object as a reusable resource. So what we can do is open up our asset browser, pick a directory or create one that you want to save it to. and then just drag and drop it into there. And now that you've done that, you can create a new project. Open up your asset manager, double click that, and here it is, ready to roll. And let's say you wanted to use a female bust in here instead of a cone. You could delete the cone or hide it. And I'm just going to make sure that's dropped to the floor. Now, the reason why we can't see that probably is that the slices are way too thick. So let's change these down to some reasonable number. Whoa, not 0. 1 works. What about fractional, like 0.5? Yeah, that works. So you've got this reusable asset now where you can just drop something in there, and this all should work, including the slices. And you remember to rotate it. We could do a quick test of, well, let's make this back, turn this to 1. All right, 1's good. And let's try something interesting. How about we do 45 here. 45 degrees. And drop that to the floor. And go here and make this minus 45. So that's an interesting sculpture. Probably look better with smaller, let's say 0.75. Interesting. And that about wraps it up. Thank you very much for sticking with me through this. I hope you enjoyed the content, or at least found it somewhat informative. Please feel free to check out my other tutorials, and please consider subscribing. See you next time.